Okay, so third unit, we are going to do probably one of the more important things in this class. It's probably something super familiar to you. If you've had any algebra in the past, and I assume you have, you've been algebra to death in your high school years, and you just want to get through this as fast as you can so that you don't have to take any more algebra. Okay, so you've seen this, but here's the thing. Again, my assumption for you, I'm teaching an intermediate algebra class. My assumption is for almost all of you, your next step is college algebra. And just in my college algebra today, we used what we're talking about today. I don't have time to re-explain it. It's something that I assume you know. So I would ask you, you clearly put in some work in the second unit. You guys did great on the, almost everybody improved their grade over the first test. So what I would ask you to do is put in a like effort on this one too. It'll pay dividends for you going forward in your next math class after this. So what we're going to talk about in all of chapter 5, and starting with section 5.1, is we're going to talk about factoring. I'll define that term in case you've forgotten what that means. And specifically in section 5.1, we are going to, we're going to factor in the common factor. That's reusing the word. One of them's a verb, one of them's a noun. And we're going to factor out the common factor in this section. So before I do that, though, you might be saying, well, that sounds like fun, Berkster. I'm glad I came today, but what does it mean to factor something? Like, what am I looking to do? That's a great question. What we're doing when we factor something is we want to basically unmultiply it. Okay, we want to write something as a product. Okay? We want to write something as a multiplication problem. Okay, that is our goal and our aim. Because sometimes it's useful to multiply things together and then be able to simplify. Other times you're going to do things and it's going to be handy to factor, to write it as a product. In fact, in this class, after this third unit, where we talk about factoring, when we get to the fourth unit, almost everything we do in the fourth unit involves factoring at some point. Okay, so it's going to be useful for us. And if for no other reason than your immediate future, because you want to do good on these next two tests. So we want to write things as a product. So I'm going to start on the ground floor. I'm hoping you recognize what we're about to talk about, but in case you don't, then great, ask questions and we'll learn. So we're going to start off with this. We are going to factor. Your instructions will always be to factor completely. So this is the instruction for everything we do for the rest of today. I'm not going to write it anymore. Factor completely. And here is the first thing, 9x plus 18. So now I look at this, 9x plus 18, and the question is, what do these two things have in common? What factor, what part of them is in common? So 9x and 18, those are my separate terms. Remember, things separated by a plus or a minus sign are our terms. What do these two terms have in common? Okay, they both have a 3 in them. And then so we're going to do this two ways because that's why I picked this problem. So if your answer to this was 9 is 3 times 3 and 18 is 3 times 6, they both have a 3 in common. That's great. Or what I would have said, and I think I heard somebody mumble, but maybe I'm just making that up. I would have said 9 times x has a 9, 18 is 9 times 2. So, and I'm going to talk about both of these. That's why I picked this problem first. So if you were a 3 person, you did 100% correct. Okay, so there's nothing wrong with what you did at all. So then we are unmultiplying. So what I'm going to do, there's two ways to ask this question. You can say, okay, what here times 3 would give me 9x? What times 3 is 9x? 3x. Or the other way you can think about that is by dividing. 9x divided by 3 leaves 3x. Just depends on how your brain works and how you like to see it. What here times 3 gives me 18? 6. We'll come back to this in just a minute because this one's not done. Okay, that's the difference between those who said 3 and those who said 9 on this problem. I'm redoing this now with the 9. So if you said 9, you saw that both of these had a factor of 9. Well, 9x divided by 9 leaves x. 18 divided by 9 leaves. Here's the difference. Both are great first step. The difference is here, I still have a common factor, okay? And sometimes that's great. You got to reduce it so that it's a number that you can recognize. What's the common factor between 3 and 6? Another 3. Yes, 6 is 3 times 2. 3 is 3 times 1. They both have another 3. There's no common factor left here. This one's been factored completely. This, we did it in 1 step. For those of you who saw 9, this, you're going to do it in 2, and that's okay. There's nothing wrong with doing these in 2 steps. So what I'm going to do is this 3, I'm just going to draw an arrow, and I'm going to put it right here, and then times, and then what I was told is 3x and 6 have a 3 in common. 3x divided by 3 is x. 6 divided by 3 is 2. And then last but not least, outside the parentheses, 3 times 3 is 9. So if we do any other problems that involve factors that can be divided up, and you don't do it all in 1 step, remember, that is okay. There's nothing wrong with that. The last thing I want to mention, I'm not going to do this on all the problems, but I think it's a good habit when you're doing homework. I just don't have time to do it. The way to check your answer, since we have factored, we've unmultiplied, the way you can check your answer now is you can redistribute. Okay, so the check is you can multiply this. So the nice thing is on this test that you're going to take, whenever, I don't know when it is, I got to look at the calendar, but this test that you're going to take, you should leave knowing you've got everything right. Okay, because you can multiply. 9 times x is 9x, 9 times 2 is 18. Good, we got it. So here's just a couple problems for you to go ahead and factor out the common factor. If you have any questions, please raise them so that we can get them out in the open. So here's your first problem. You've got, this one's just going to have 3 terms instead of 2 to have 50% more fun. So we've got 28x squared plus 21x plus 35. Okay, so if you got your calculator, if you need to fiddle around with the factors, that is fine. Go ahead and pull your calculator out. Factor that completely, please. All right, so what factor do 28, 21, and 35, what do they all have in common? 7, okay? When we are factoring out the common factor, it has to be something from all 3 or both or however many terms there are, you've got to factor the same thing out of everything. So they all have a 7 in common. So when I factor 7 out, what's left from 28x squared when I factor the 7 out? 4x squared. 7 times 4 is 28. What's left from the 21x when I factor the 7 out? Okay, 3x. 7 times 3 is 21. What's left from the 35 when I factor the 7 out? Perfect. There you go. Then the last question you should always ask yourself, now that I've reduced these numbers to something a little more manageable, is there anything else in common? 4 and 3 and 5, do they have any other factors in common? No, 3 and 5 are prime. They don't have any other factors except for 3 and 5. So we are done with this problem, and I can move on to the next one. Here's another one. I'm just going to practice this a whole bunch of times. So I want you to get good at it so that when we do problems here and in college algebra involving factoring, you feel super confident about it. So here is another one. 15x squared plus 25x plus 5. What's the factor that 15, 25, and 5, what do they all have in common? 5. Now I gave this problem with a reason, so if you messed up my reason for this, again, mistakes are not an issue. They're opportunities to learn, okay? So make a note and learn if you make the following mistake. 15x squared, when I factor out the 5, what's left to put right here? 3 times 5 is 15. 25x, when I factor out the 5, what's left? 5x. Here's the 1. Here's the bit. Okay, so pay attention. 5, when I factor out the 5, what's left? 1. Yes. So if you stopped the problem here, you've changed the problem. Okay, this is the most common mistake on factoring out the common factor. I will put a problem like this on the test when we have it. Okay, you've changed something that had 3 terms into something with 2 terms. So this is fundamentally different. When I do my division, remember we're undistributing. Okay, we're unmultiplying, which is division. 5 divided by 5, you said correctly, is 1. You have to put a 1 here. 1 times 5 is 5. That is the factored expression right there. Okay, so don't forget that 1. Common mistake. All right, we're going to do one more with numbers. And then we're going to talk about, okay, what happens if I have a variable or 2 in this as well. So try this one. Let's say that you have 6y plus 24. Factor that completely, please. Six y and 24. What factor do those 2 things have in common? 6. Now, if you're at your paper and you started with a 3 or a 2, that is a legitimate first step. So don't erase, don't beat yourself up. Okay, you're just going to do something in 2 steps that I'm going to do in 1 step. Okay, and that is totally fine. So I'm going to factor out the 6. When I start with 6y, I factor out the 6. What's left? And then yes, 24, we factored out the 6, 4. I'm not hearing a whole lot of voices, but that's kind of normal for this class. Are we doing okay? Okay, remember your multiplication table. if you're struggling with the factors, get your calculator out. You can't break your calculator by plugging in numbers. Okay, so just make sure that you're messing around with these. It's just a little bit of arithmetic. Okay, so like I said, now what happens if I have some variables? So if I have 5x to the 4th plus 2x squared. Well, between the 5 and the 2, there's nothing in common, but both terms have x's. Okay, they both have x's in common. How many x's are in this first term? 4. How many x's are in this second term? 2. So if I need to take out the same number of x's from both terms, how many can they both give me? 2, right? X squared. They can both give me 2. I can't take more than 2 because this one doesn't have enough. So just in short, okay, if you want a simple way to remember, okay, when you have to factor out variables, you always factor out the smallest power. It's always the smallest power. So you might ask, hey, Perkster, why didn't we factor out any variables before this one? Well, if you look at this problem right here, there's 2 x's in the first term, there's 1 x in the second term, but then how many x's were in this term? 0. So there wasn't any in common to all the terms. That's why this is the first problem that we've addressed this. So I was already told we're going to take out x squared, we're going to take out 2 x's. Okay, so here goes. I started with 5x to the 4th, I took out 2 of the x's. So what's left in the first term? 5x squared, okay? Remember, when we multiply our bases, we add the powers. 2 plus 2 is 4, great. I started with 2x squared. I took out the x squared. What's left for the second term? Just 2. Okay. No more x's. Don't write x. Don't write an x there. We took both the x's away, so it's just 2 now. Try this one, same sort of thing. And then we're going to do both at the same time. We're going to have numbers and variables. It's going to be just a plethora of factoring. So try 7y to the 6th minus 5y to the 3rd. Please factor that completely. How many y's can each of these donate to me? 3. Okay, so I'm going to take out y to the 3rd. When I factor out y to the 3rd out of the first term, what's left? 3 plus 3 is 6. When I factor out y to the 3rd out of the second term, what's left? Okay, so here's the next problem. I'm going to give you a moment or two to make the best of it you can. There's going to be coefficient and there's going to be variables that you have to factor out of these terms. So give it your best shot. Any mistakes you make, you're going to learn from. So here we go. We've got 24p squared minus 9p to the 3rd plus 6p to the 4th. Okay, factor completely. There's a little bit of everything going on in this problem. Okay, so if you're struggling on where you're starting, or if it's just a lot of information all at once, I can totally understand. So let's look at these as two separate parts. Forget the variables for just a minute. I've got a 24, I've got a 9, and I've got a 6. I'm only worried about the coefficients. What's the common factor to 24, 9, and 6? 3. Now I'm going to forget the coefficients. I'm just going to look at the variables. I've got 2 p's, I've got 3 p's, I've got 4 p's. How many p's can I factor out? Always the smallest power, 2 p's. Yep. Again, when I'm factoring, just think one part at a time if that helps you. So if I've got 24, I factored out 3, that leaves 8. I started with p squared, I factored out p squared, so no more p's in the first term. Minus 9, I factored out 3, leaves 3. P to the third, there's 3 p's, I factored 2 of them out. How many does that leave for right here? And then 6, I factored out 3, that leaves 2. P to the fourth, I factored out p squared. How many p's does that leave me? Here's another problem. But let me do one before I have you do one, and then I'll have 2 more problems like this, and then we're going to apply factoring out the common factors. So here's the next one. Let's say I have this m squared, n to the fourth, plus m to the sixth, n to the third. Give me a second to write that down, and then we are going to factor it completely. So now each term has 2 variable parts. It just doubles our fun. I'm going to consider them separately. First, my m's. I've got 2 m's, I've got 6 m's. How many m's can I factor out of this? 2, that's right, m squared. Now I'm going to look at the n's. I've got 4 n's and I've got 3 n's. How many n's can I factor out of this? Always the smallest power, n to the third. Indeed, that's true. Always the smallest power. Now I'm going to see what's left from each of these terms. Again, I'm going to consider each half. I started with 2 m's, I factored out 2 m's. There's no more m's in the first term. I started with 4 n's, I factored out 3 of them, so that leaves 1. Plus, started with 6 m's, factored out 2 m's. How many m's does that leave for the first term? Started with 3 n's, factored out 3 n's. No more n's in the second term. We're done. Nothing in common. Okay, I've got 2 more problems of factoring out common factors when there's coefficients and variables. So no time like the present if you have a question to ask it. Okay, so here is the second to last one of these, and then just a couple more things from this section. So I have 9x to the third y squared minus 3x squared y squared plus 6x squared y to the fourth. So please factor that completely. All right, so let's look at I'm gonna look at coefficients, I'm gonna look at x's, I'm gonna look at y's, and we're gonna make our decision. So among 9, 3, and 6, what factor do they have in common? X cubed, x squared, x squared. How many x's can I factor out? Y squared, y squared, y to the 4th. How many y's can I factor out? Again, 2. Nine divided by 3 leaves 3. Started with 3 x's, factored out 2 x's, leaves me 1. Started with 2 y's, factored out 2 y's, no more y's in the first term. Minus 3 divided by 3 leaves 1. Started with 2 x's, factored out 2 x's, no more x's from the middle term. Started with 2 y's, factored out 2 y's, no more y's from the middle term. Plus 6 divided by 3 is 2. X squared, I factored out x squared, no more x's. Y4 divided by y squared, I started with 4, I took out 2, leaves me y squared. There we go. Here is another factor out the common factor problem, and then we're going to move on to applying factoring out the common factor. So it looks like this. 25 a to the 4th and b to the 3rd, plus 15 a to the 5th, b to the 6th, minus 20 a to the 4th, b to the 6th. Give that your best effort, please. So let's give this a try, see how you did. So 25, 15, 20. What factor can you take out of all 3 of those? A to the 4th, A to the 5th, A to the 4th. How many A's? 4. B to the 3rd, B to the 6th, B to the 6th. How many B's? 3. Great. Excellent work. There you go. Now what's left? 25 divided by 5 leaves 5. Started with 4 A's, factored out 4 A's, no more A's. Started with 3 B's, factored out 3 B's, no more B's. Plus 15 divided by 5 is 3. Started with 5 A's, factored out 4, have A. Started with 6 B's, factored out 3 B's, B to the third. Minus 20 divided by 5 is negative 4. A to the fourth divided by A to the fourth. B to the sixth divided by B to the third. B to the third. 3 plus 3, 6. But that's factoring out the common factor. That's our first skill for the day. Second skill, okay, is related to factoring out the common factor. My math lab likes these problems. I don't exactly know why they're so obsessed with them. They're not actually, I don't think, that hard once you've done 1 or 2 of them. So let me mention this. Let's say you have a problem that has a negative in front of the first term. So we have negative x squared plus 5x minus 14. Negative x squared plus 5x minus 14. So the thing to notice is I've got a negative here in front of the first term. And you might be asked to factor this. This is a handy thing to do when we get to the next section that we're going to start today. But it's not as big of a deal as our book makes it out to be. So when you have a negative in your first term, it tends to make some of the factoring we do a little more complicated. So what we're going to do is we're going to factor that out. So there's nothing else in common to these terms. So what I'm going to do is I'm going to factor a negative out. And all you're doing now is you're changing the sign. So if we start negative x squared, what's a negative x squared divided by a negative? What does that leave me? Positive x squared. What's a positive 5x divided by a negative? What does that leave me? And then a negative 14 divided by a negative, that leaves me a plus 14. And then we're done. That's all you have to do. So when you're asked to, when that first term is negative, and you're asked to factor it out, you're just factoring out a negative and then changing the signs of the things. So here's one for you, just so that you can practice actually going through this. So minus y squared minus 7y plus 25. So do the same thing, factor out that negative. So we factor out the negative out of this because it's the front of our first term. So when I do that, when I factor out the negative, what's going to be left from my first term? What's the new one right here? Positive y squared. What's my second term going to be? Plus 7y. Negative divided by negative is positive. And then what's my third term? Positive divided by negative is negative. Yes, indeed. Great. Okay. So before we get to the very last thing, we're going to do one of these types of problems. It's still factoring out the common factor. Let's say I have this. Let me give you a second to write this down. X minus 5 times x plus 6 plus x minus 5 times 2x plus 5. Give you a moment. There's a bunch of terms to write down there. Okay, so you've had a second to write this down. So here's the thing. I still have something that has a common factor here. The difference in this problem and the ones that we were doing before is our factors look a little different. Instead of being just single things, they are what's called binomials. There's two terms. So what I have here is I have, this is my first term, and then this is my second term. The stuff being multiplied together makes a term. Okay, so even though there's the two binomials, they're being multiplied together, that's why that's a first term. Even though there's two binomials here, they're being multiplied together, that's why that's the second term. So looking at this, here's the big question. Looking at this, looking at my two terms, what do you see that is in common to both of these terms? What do they have that looks exactly alike? The x minus 5. Yes, there's this x minus 5 right here, and then there's this x minus 5 right there. Those are the two bits that look exactly alike. So what we're going to do is we're going to practice factoring out the common factor. This is going to be a useful skill for us for today, but then also when we come back next week on Monday, when we try to factor things that are more complicated. Being able to identify a common factor like this is going to be really helpful. So I've got an x minus 5. I've got a single x minus 5 in each of these, so I'm going to factor it out, x minus 5. It's not x minus 5 squared, common mistake. I am not multiplying these two things together. Neither of them have two x minus 5s. It's just one x minus 5. I'm taking out of each of them. Now my first term. When I factor out the x minus 5, what's left of that first term? The x plus 6. This is the bit that's left right here. I've gotten rid of this x minus 5. I'll cover it up. The thing that's left is the x plus 6. Plus second attempt at the same question. The second term, when I factor out the x minus 5, what's the bit that's left from that one? Yep, I cover up the x minus 5 that I just factored out. Use your thumb, and you're left with 2x plus 5. One more step. Almost there. Once you've taken out that common factor, you have these two things. There's a plus sign right here, so I put the plus sign right there. That tells me I can now add the like terms. So x plus 2x in the parentheses is 3 of them. 6 plus 5 is 11. Here's a problem just like that. You'll see this again. This is not going to go away. This is going to be part of a bigger problem. This is like the last step of a bigger problem that you're going to have. So I'm trying to show you what we are going to do on Monday. You're seeing kind of the individual steps, and then on Monday we're going to tie it all together into one problem. So this is the what will be the second, the last step when we get back on Monday. So here's one just like that for you. You're doing the same thing. So you've got this 3x minus 2 times x plus 1 plus 2x minus 5 times 3x minus 2. So there's a common factor in those two terms. I would like you to factor it out and then simplify what's left over. All right, what's the factor that's in common to both of these terms right here? There's a 3x minus 2 right here, and there's a 3x minus 2 right here. Great. That's the thing that looks exactly the same. So I could factor it out. I will do that. 3x minus 2. When I factor out the 3x minus 2, what's left from the first term? Cover this up. X plus 1. Plus, I cover this up. What's left from the second term? X plus 2x is 3x. 1 minus 5 is negative 4. There is your factored expression. Okay, so all of that to build to this. What we're going to do now for a few problems, this will be the middle step of what we talk about on Monday. Okay, so we've showed you the last step, I'm showing you the middle step, and on Monday I'll show you the first step of this bigger process. Okay, so you'll see this again, you're going to use this quite a bit. What we are going to do now, because our goal is to be able to factor things that are all multiplied together, what we're going to do is we're going to look at a process called factoring by grouping. We are going to factor by grouping. You might be saying, well, that sounds really fun, Brickster, but how do I know when I'm going to factor something by grouping? And that's a great question. In this class, because we're just learning, this is the introduction to it, we know we're going to factor by grouping when something has 4 terms. That's the time for us that it's going to be its most useful. So for instance, here's a nice, we're just going to work here with some nice simple things. Simple doesn't mean easy. Simple just means fewer things to look at. So I've got ax minus ay plus bx minus by. I'll give you a minute to write down those 4 terms. Okay, so here's the thing. Do I have something in common? Do I have the same thing in common to all 4 terms? Is there any one thing that is the same in all 4? No, you're right. I've got A's, but I only have A's in 2 terms. I've got X's, but I only have X's in 2 terms. Y's and B's, again, only in 2 terms. There's nothing that is in all 4 terms. So I'm just going to make a little note over here that there is nothing in common to all 4 terms. If there is, factor it out. But we're not going to give up on factoring this. We still want to see if we can. So here's what we're going to do. This process of factoring by grouping, what you do is you first start by grouping. You group the first 2 terms and you group the last 2 terms. So instead of thinking about all 4 terms, I'm going to consider the first 2 terms as a unit. I'm going to consider the second 2 terms, or the last 2 terms as a unit. So instead of thinking about the whole problem, I'm breaking it up into half and half. So now, forget the last 2 terms for a minute. We'll come back to it. What's in common to the first 2 terms? Sure. There's an A. AX, I factor out the A, there's X. Negative AY, so I'll put a minus. AY, factor out the A, I've got Y left. The same thing, I'm going to cover up the first 2 terms. What's in common to just the last 2? I don't care about anything else. The B, yes, plus B. And BX, when I factor out the B, I have X. BY, when I factor out the B, I have minus Y. So now, what's left is just what we were doing a minute ago. Okay, I've got these two terms. I've taken something with four terms. I've factored something out of the first two. I've factored something out of the last two. I've turned this thing with four terms into something with two. What do these two things have in common now? What looks exactly alike about both of them? There's an x minus y right here. There's an x minus y right here. That's how you know grouping has worked, when you have the exact same thing in both terms. Now we can do just what we did here a second ago. I'm going to factor out the x minus y. When I factor the x minus y out, what's left from this first term? When I cover this up, what's left? Yeah. When I factor out the x minus y, when I cover it up, what's left from the second term? There you go. Now, I know we haven't talked about it in this class. This is something we do in our introductory algebra class, so we assume that you come in knowing this. If I want to multiply these two things together, what's the acronym that I use to multiply two binomials together? Anybody remember? No one's taught you the acronym? Oh, we'll talk about multiplying. I'll introduce it in a few minutes. Foiling. First outers, inners, last. You don't have to remember the acronym. Just people give it to you to remember to multiply all four. So you multiply the firsts, you multiply the outers, the inners, the last. I'll review that real quick in a minute because I got a lot of stairs there, and I don't want to avoid that if we need to talk about it briefly. Foiling, yes. Because remember, multiplying is the antidote to factoring. So again, if you want to know if you did this right, you multiply this and you should get what you started with when you do your first outers, inners, lasts. Okay, multiplying always checks your factoring. So here's one just like that for you. It's a very similar problem. So I have 3m minus 3n plus xm minus xn. Please factor that by grouping. Okay, so once again, there's not anything in common to all four terms. So I'm going to consider the first two as a group. I'm going to consider the last two as a group. What did you factor out of the first two? What do they have in common? 3m, factor out the 3, got m. 3n, factor out the 3, got n. xm, xn, the last ones, I have an x in common. So xm, factor out the x, I have m. xn, factor out the x, I have n. Did the grouping work? Do I end up with the exact same thing in both the parentheses? Yes, it did. That's how you know. If you don't have the exact same thing, you made an arithmetic mistake. Go back and check. Okay, so the same thing here, same thing there. So I will now factor that out. And now when I factor the m minus n out of the first term, I'm left with 3. When I factor the m minus n out of the second term, I have x. Here's another one. Here's 4 terms more for you. 2ax plus 4bx plus 3ay plus 6by. Okay, once again, there's not something in common to all four terms. So I'm going to group the first pair, I'm going to group the second pair. So now in the first pair, I've got a 2a and an x, a 4b and a y. Or so not a 4b and a y. Let me start over. I got a 2a and an x, a 4b and an x. What do those two things have in common? Okay. There's a 2 in common. Great, I'm glad you noticed that. And then they both have an x in common. Wonderful. So I took the 2 out, the a, and then I factored the x out. So all that's left on the first term is the a, the 2 and the x I factored out. 4 divided by 2 leaves 2. And then from bx, I factored the x out, and I'm left with b. Plus 3ay plus 6by. What's in common to those two terms right there? So the 3 I factored out. I started with ay, I factored out the y, I'm left with a. 6 divided by 3 is 2. by divided by y is b. So now they got the a plus 2b in common. From first term, there's this 2x that's left. From this second term, there's a 3y that's left. And there's my finished factored expression. All right, once it clicks, grouping never changes. It's always the same thing. I just want to address one other thing, and then we'll do 2 or 3 or 4 more. Maybe you've noticed I haven't mentioned y yet. We've had a plus here every time. Okay. So how do I know it's a plus? How do I know that that's not a minus? That's a great question. Okay, so here is an example that I have, and we're gonna talk about it. So let's say I have this. I've got 3x minus 3y minus ax plus ay. Okay? Try to keep the terms simple while you're learning grouping. So that, this one was a little more complicated, but I'm trying not to put like lots of powers and stuff in there right now, because I know that probably for a lot of you this is novel, and I don't want to create a lot of problems just yet. So I'm going to group. There's 4 terms. There's not anything in common to all 4 terms. So I'm going to look at the first 2. I'm going to look at the last 2. So here goes. First 2, we've seen a problem super similar to this. The first 2 terms, I can factor out the 3. 3x divided by 3 leaves x. Negative 3y divided by 3 leaves negative y. Now here's the thing. My second pair of terms. Don't just assume a negative because this next term is negative. Okay, that doesn't have to mean that you're factoring out a negative. What I'm going to do is I'm going to be oblivious. I'm just going to say, okay, I'm going to factor out a positive a. I'm going to factor out a positive a. I want to note the result, and this is going to tell me in case I didn't know. Now, I'll give you the shortcut after we note this. Okay, and then you can hopefully develop the skill to see, do I have to factor out a positive or do I have to factor out a negative? If I factor out a positive, when I factor out the a, I'm left with negative x. There's a negative here and there's an x. I'm left with negative x. When I factor out the a out of this, I get positive y. So here's the question I've asked on the other problems. Do I have the exact same thing in the parentheses? No. This is a positive x. This is a negative x. This is a negative y. This is a positive y. I don't have the exact same thing. But here's what I do notice. The signs are opposites. This is positive, negative. This is negative, positive. The signs are opposite. When you notice, if you ever do a problem and you notice that you have just the opposite signs, that means you should have factored out a negative here. Up here, you could have noticed that. I've got a positive x term, I've got a negative x term. I've got a negative y term, I've got a positive y term. That could have been an inkling. As you get better at this and a little more experience, you could see ahead of time that you needed to factor out a negative. So I'm just going to go back and I'm going to change that. Instead of a positive, let's factor out a negative. So now I factored out the negative and the a. There's the negative and the a. So a negative divided by a negative leaves a positive x. And then here, a positive divided by a negative leaves a negative y. Now I've got the same thing in parentheses. So I'll factor it out. When I factor out the x minus y from the first term, I've got 3. When I factor out the x minus y from the second term, I have a negative a. And there we go. For the first time, I factored out a negative. So I'm just going to have you do 2 more problems. And then we're going to be done with our first section for the day. And then we're going to start the second section. We're going to do the first bit from there. And then we'll come to a nice conclusion for the week. So try this problem, same sort of thing, not much different, keeping the terms nice and simple so that you don't have to worry about that. So AB minus 7A minus 5B plus 35. So on this problem, just like the previous one, here's what I notice. I've got a positive AB and I've got a negative 7. I've got a negative term with a B in it, and then I've got a positive, and 35 is 7 times 5. So my signs are the exact opposite. So this is another situation where in the middle, I'm going to factor out a negative and make the signs the same. So here we go. I'm going to group my first 2 terms. I'm going to group my second pair of terms. So out of the first 2, I can factor out an A. AB divided by A leaves B. Negative 7A divided by A leaves negative 7. So again, my term here with the B is positive. My term here with the B is negative. So that tells me, that's my clue. that I probably should factor out a negative. So I'm going to do that. I'm going to factor out a negative, and then in addition, 5b and 35 both have 5 in common. So a negative 5 divided by a negative 5 is a positive, and it's a positive b left over. And then positive 35 divided by negative 5 is negative 7. And once again, my grouping worked. This is great news. Otherwise, I'd be frustrated. By the way, on the test that I give you, my guarantee to you is everything will be factorable. Okay, there's not anything that you're going to look at and you're not going to be able to factor. I don't want to frustrate you trying to teach you how to factor. Okay, so everything will be factorable. And then here we've got a minus 5. When I factor out the b minus 7, I'm left with a. When I factor out the b minus 7, minus 5. All right, here's our second to last problem from this section. Okay, so you're down to your final 2. Try this one, same sort of thing. I've got 3ax plus 6xy minus a minus 2y. All right, so I'm going to get started on this problem. Then we've got one more, and then we're gonna start the next section. Which what we're going to start is probably something that you remember from a previous class. So I've got 3ax plus 6xy. So between 3 and 6, I have 3 in common. Between ax and xy, there's an x in common. So when I start with 3ax and I factor out 3x, I'm left with a. When I start with 6, factor out 3, that leaves me 2. xy, factor out the x, I'm left with y. Here's the thing that I was hoping you noticed, and if you didn't, this is your chance to learn. Both of these terms that come next are negative. Both the things in parentheses are positive. So that tells me I have to factor what out of both of these terms right here? Negative, I'm going to call it a -1. You don't have to write the 1. Is there anything else in common between the a and the 2y aside from the negative? Nope. So a negative a divided by -1 is positive. A negative 2y divided by -1 is positive 2y. And then once again, I notice my grouping does work. That's good news. I wouldn't have had to do it otherwise. When I factor out the a plus 2y from the first term, I have 3x. When I factor out the a plus 2y from the second one, I have -1. One more problem, then we'll stop this video and start a brand new one. The last thing is we're going to work this one together. P squared q squared minus 10 minus 2q squared plus 5p squared. I'll give you a moment to write this down. 4 terms. Sometimes this is going to happen to you in the homework, so I just wanted to bring it up now. So when I go to group this, it's got 4 terms. I've told you everything's going to factor on the test. So when I go to look at my first 2 terms, here's the thing that I notice. P squared q squared minus 10. What's in common to p squared q squared minus 10? Nothing. Yeah, exactly, nothing. So it's going to be kind of hard to do grouping if nothing factors out to make this look any more similar to that. So when you encounter this situation, okay, when you have 4 terms, there's always one group, there's always one order that won't factor, even if this thing in general will. So here's my recommendation. Just change the order. What I'm going to do is I'm going to take this -10 and I'm just going to throw it to the end. For no other reason than I'm just going to get it to the end of the train. So I'm going to start with p squared q squared. I'm going to put the -10 to the end. So the next term is going to be -2q squared plus 5p squared and then -10. You could have, if you wanted to, just flipped the order of the -10 and the -2q squared. You could have put the 5p squared and the -10 in a different order. There's other arrangements that would work, okay? But the way this problem started was not going to work. So now I'm ready. Now I'm going to group. Now my first 2 terms are p squared q squared minus 2q squared. What's in common to those 2 terms? That is true. Thank you. P squared q squared. I took the q squared away. That leaves me p squared. -2q squared. Took the q squared away. Leaves me -2. The second pair of terms, I got 5p squared and I've got -10. So there's a 5 in common to both of those. When I take out the 5 out of the first term, I'm left with p squared. When I take out the 5 out of the second term, -10 divided by 5 is -2. So the whole point to this problem was just I wanted you to know that if grouping doesn't work in the order you're given, try changing the order. Okay, and grouping will likely work then. So when I take the p squared q squared out of the first term, I've got q squared. When I take the p squared minus 2 out of the second, I've got +5, and there is my final result. So in short order, there is factoring out the common factor and grouping. That's a lot of stuff.